Lead bricks so that other alpha particles should not go here and there for that reason. Okay, alpha particles should not go here and there for that reason. Use lead bricks. Okay. Now, so then this screen is zinc sulfide screen or zinc platinum cyanide screen. Zinc sulfide screen is taken here so that scintillations can be seen. Scintillation, small angle scattering of most. Small angle scattering. Small angle scattering of most. Small angle scattering of most. Alpha powdering experiment is deleted or is there? Again, tell me beforehand. Joshua, is it there are atoms, alpha particle? This is there in the syllabus. Okay, thank God.
Atom is nothing is deleted.
What is there? Alpha, Rutherford model, Bohr's model, energy level, hydrogen spectrum. Yes, everything is there almost.
So what are the lead bricks for?
Well, yeah, explain. Just copy this and explain. Explain the diagram. Both the diagrams are explained. So small angle scattering almost. Okay. Outmost. Offmost. Not utmost, offmost. Okay, now see here, in this experiment, yeah, okay, okay. Now see here, in Rutherford alpha scattering experiment, Rutherford was the first person, she is the second person. After J.J. Thomson's atomic model, Rutherford has explained this model. According to this model, he did not explain this experiment, alpha scattering experiment. So he took the source of alpha particle, like best example is like cesium. Okay, Ce I think, cesium. Ca means calcium, yeah, cesium he has taken, or Cs I don't know. Yeah, Cs I think. Let's check cesium element, the symbol of the cesium. Cs, okay. So he has taken cesium, that is source of alpha particle. Then the gold foil is of very thin. You know, it is in micrometer, 10 to the power of minus 6 meters. It's very thin, 10 to the power of minus 6 meters. Why he has taken that much, and why only gold? Two important things. Because gold has a very important property called malleability. It has an important property called malleability. What is the meaning of malleability? Yeah, it can be transformed into sheets, very thin sheets. The important thing is why? Because if you keep on rolling, you won't get patches. Gold becomes thinner and thinner, like it becomes like a foil, thinner like a foil. Have you seen these sweets sometimes which come from India, there are very thin foils of silver thin foils. Okay, we take that small piece in a paper and they hammer with the wooden hammer. Then what happens? It becomes very very thin. If you touch it, breaks. So this type of things, this is put on the sweets for decorative purpose, and it is good if you take it. If you eat, also not a problem. Okay, it's good for health. So that's the thing. So same way, aluminum is gold is also having a property called malleability. Malleability means it can be formed in sheets, that is 10 to the power of minus 6 meters. And also one more thing is, he wanted like in one layer as minimum number of atoms possible, so that he can exactly see how the scattering is taking place. Even then he says that some 20 atoms at one time or more than that. So many atoms are there. Even then, if you made it very thinner and thinner, there are so many atoms present. Okay, now this is a screen. This screen is made up of zinc sulfide or zinc platinum cyanide. We are able to hear zinc sulfide screen or zinc platinum cyanide. And now in the second one, the same thing. This and this is same. But now if you see, this is the source and this is the lead bricks. Why lead bricks? Lead is the element which stops alpha particles or beta particles or gamma particles to spread here and there. That is why this is also lead box. This is also lead box. We keep it in the lead box. Okay. Why lead box? Because it will stop the alpha particles to come out. And lead is the end product of most of the elements, most of the radioactive elements. That's the reason. Even in petrol also, we have lead unleaded petrol. And maybe if you go to India, you can see unleaded petrol. Here we are not saying unleaded petrol, we are saying special and super. The name is same. Unleaded petrol and some other name is there in India. Means lead is to be removed. Okay, lead is removed from the petrol, so that what happens, it doesn't spoil the atmosphere. That's the reason. So we have unleaded and super. The same way here also we have special and super something. Now this is lead which stops the alpha particles to spread here and there. Okay, it will only go in the beam now. So beam of alpha particle. Now this is the gold foil, and this gold foil is fixed between two ends, two supports. Now what happens, these alpha particles will scatter here and there. It will scatter in all the directions. So small angle scattering of most of them go straight. Okay, most of them they go straight, and very few they scatter. Means they scatter in all the directions. So you can see this screen is made up of zinc sulfide or zinc platinum cyanide. Whenever alpha particles hit the surface or the film or the screen, then what happens? It shines like sparks. Okay, sparks are, it can go with spark. It can. So what happens is, here it will the sparking takes place. Clear? Sparking takes place. That's the reason. Or there can be a sparking, or there can be like shining, something like shines on it. Okay, that's happening. So this is a detector. We can also see we can also take a microscope. Now we will see the behavior of the scattered particles with the scattering angle. That we will see now. We will draw the graph for that and we will discuss about that. And after that, we will discuss about the observation. Then we will discuss about the conclusions of Rutherford alpha experiment. Then we also will discuss Bohr's experiment also. Clear? Now, are you clear with this, Johan and Joshua? Yeah. Now we have here the graph. This graph, how many are there? 10 to the power of 7, up to 10 to the power of 7. 1, 2, 3, 4, 5, 6, 7. Then here 0 to 180, 20, 40, 60, 80, 100. Yeah. 20, 40, 60, 0, 20, 40, then 60, 80, 100, 150, 120, 140. These are the angles. Okay, 140, 160, then 180. This is 180. Okay. And the other one is 10 here. We'll start with 10, 10 to the power of 2. 10 square, 3, 4, 5, 6, then 7. 10 to the power of 4. We'll take like this. Now, from 10 to the power of 7 it starts like this here. It goes in this way. Then the second one here, third one is here, fourth is here, fifth one is somewhere here, sixth one, and this is it. See, this is the thing. So scattering angle theta in degrees. Scattering angle. Degree, and then number of scattered particles detected. Number of scattered particles detected. Okay. Number of scattered particles detected. Okay. Then what exactly he found out, that also we discussed here. Suppose this is the nucleus. See here.
And that is the number of scattered particles.
Yes, these are the number of this y-axis is number of scattered particles. X-axis is scattering angle, which is theta. That is from 0 degree to 180 degree, and this is 10 to the power of 10 to 10 to the power of 7. So most of the alpha particles they go straight. That's the meaning. Angle is very less. Copy this. We'll go ahead. Construction. What are the conclusions we get from? Yeah, I'm writing that. I'll discuss the conclusions and observations of this graph. Sorry. Down. Down.
What's the graph for?
This is not graph. That is how the scattering is taking place. That I am explaining. Finish? Okay. Now here, let me write see one more thing here. See, if you see here, these are all the alpha particles. I'm just explaining. So if you see the alpha particles here, it goes like this, which are very close. See, one in 8,000 or 10,000. They say that I'll write the conclusions here. So the conclusions of this alpha, that is alpha scattering experiment. Number one, that is 1 in 8,000 or 1 in 10,000 undergo head-on collision. Undergo head-on collision. Okay, undergoes head-on collision. Number one. Second one. So what is happening? See, 1 in 8,000 undergoes head-on collision. Second one is, some books it is 10,000 also. Not a problem. See, the closer the alpha particle, the diffraction is more. Okay, closer the alpha particle. So the rays, the alpha particles, which are closer to the head-on collision, which are closer to the center, I will write, which are closer to the central alpha particle, scatters alpha particle, scatters most.
Alpha particles which are closer to the
Alpha particles which are closer to the central alpha particle. This one. That they scatter most. Okay, and the farther scatters less. Okay, they don't scatter. That's the meaning. Means the alpha particles which are very closer is scattering more. See here, this is scattering less. Now here 90 degrees, and this is almost all low, and this is nothing. Means as it is moving away, so this is a scattering angle and number of scattered. So if you look at this angle at 90 degrees, how many are there? Very few. At 180 degrees, many are there. Sorry, 0 at 0 degrees means most of them are going like this. Most of them are going straight, but very less are going in this way. At 90 degrees, maybe very few. Understood? That's a conclusion. Now next one, there is but none of the alpha particle penetrates to the nucleus. Okay, he came to conclusion that none of the alpha particle passes or penetrates through the nucleus. Okay, none of the alpha particle penetrates or passes through the nucleus. It shows that nucleus is strong. Or we can say nucleus is hard, and no particle can pass through the nucleus. Okay, nucleus is very hard. No particle can penetrate through the nucleus. Okay, and no particle can penetrate. No particle can penetrate through the nucleus. Okay, no particle can penetrate through the nucleus. Fifth one. Okay, so, and what is that? Most of the atom is empty. Okay, most of the atom is empty. Means like he has given the example. Football in the football ground. Football is the nucleus and football ground is the atom. You understood now? So he compared football with the football ground. Football with football ground. Football ground. Okay. Means football is the atom analogy. Sorry, this is football is the nucleus and football ground is the atom. That is how he has compared. Okay. And what is that? And also he explained most of the atom is empty. Here he explained nucleus is hard and no particle can penetrate. He also explained the repulsive forces. Okay, repulsive forces also he has explained here. Okay, repulsive forces means he came to conclusion that nucleus is positive in charge because of that. Nucleus is positive in charge. Okay, nucleus is positive in charge. Clear? One in 8,000 undergoes head-on collision. The alpha particles which are closer to the central alpha particles scatter most, and farther alpha scatters less. None of the alpha particle passes through the nucleus. So nucleus is hard in nature, and no particle can penetrate through the nucleus. Also he explained the repulsive forces. What are repulsive forces? Positive and positive will repel. So that is how he could say nucleus is positive in charge. And most of the atom is empty. How he compared? He compared with football to football ground. Football is the nucleus and football ground is the atom. Is it clear, Mr. Joshua and Joan? Is this clear? Okay, good. Now, just note down these points. Then we'll go to the electron. Electron orbit. Okay. Before going to electron orbit, I would like to explain Rutherford model. What is Rutherford model and what are the drawbacks of the Rutherford model? Then Bohr's model. Then I will come to the derivation. There are two derivations that I will explain the derivations. Okay. Now, is it done? Now, next one is, I'll explain. Rutherford model, then drawbacks of Rutherford model. So, what is Rutherford model say? Rutherford model. He says that so here it says that what this is at center there is nucleus which is positive in charge. It has protons, neutrons, electrons are revolving around it. He said that atom is spherical in shape. Second one, the entire mass of the atom is concentrated. His atom is concentrated at the center part of the atom, called nucleus. Third one, nucleus is positive in charge. Nucleus consists of protons and neutrons. protons and neutrons, and electrons are revolving around it. Electrons are revolving around it. Electrons are revolving around it. Okay. So therefore, this model is also known as. Therefore, this model is known as planetary model. This model is known as planetary model. Next is conclusion. There is drawbacks. Drawbacks of Rutherford model, or drawbacks or failures. Okay, drawbacks and failures of this model. See, once again, the atom is spherical in shape. The entire mass of the atom is concentrated at the center part of the atom called nucleus. Nucleus is positive in charge. Nucleus consists of protons and neutrons, and electrons are revolving around the nucleus, like planets revolve around the sun. So, okay, like planets revolve around the sun, like planets revolve around the sun, like planets revolve around the sun. Therefore, this model is also known as planetary model. Now, what are the drawbacks? He said that he gave the concept of spiral orbits. Spiral orbits means what? Electrons revolve in spiral orbits, and finally it falls into the nucleus. He said that electrons revolve in spiral orbits, and finally they fall into the nucleus, and nucleus will collapse. But it's not happening in the nature like that. Okay. So I write here, electrons revolve in spiral orbits. Electrons revolve in spiral orbits and loses its energy continuously, and finally falls into the nucleus, and nucleus will collapse. Okay, but it is found in the nature that, atom is stable in nature. Atom is stable in nature. Okay. Electron revolving spiral orbits and loses its energy continuously, and finally falls into the nucleus, and nucleus will collapse. But it is found in the nature. Atom is stable in the nature. So, nucleus is neutral. It means it has positive, negative. It is positive in charge, not neutral. The second point, he says that hydrogen atom has continuous spectra. I told in the previous class also, continuous spectrum. Continuous spectrum is like a rainbow, but experimentally it is found that experimentally it is found that hydrogen atom has line spectrum. He could not explain this. Okay, hydrogen atom has a line spectrum. It's not a continuous spectrum. Clear? So these are the two drawbacks of Rutherford model. हाँ, मिल गया PPT आपको? Okay, so these are the postulates and drawbacks of Rutherford model. Okay, you can write this as postulates. These are the postulates of Rutherford model. Yeah, postulates and drawbacks of Rutherford model. Now, clear? Any doubt in this? Yes, Mr. Joshua Jawan, is it clear? Is this clear? Okay. Now, I am going with the next, his students, okay, his student, Lord Rutherford is also known as Lord Rutherford. He got Nobel Prize and his 3 students. One of them was Bohr, Niels Bohr. Niels Bohr is a student of Rutherford. And all the 3 students also got Nobel Prize. Okay, so one of the eminent scientists of physics and chemistry was. Now, Bohr's model means Niels Bohr. Okay, so Bohr's model, he gave this explanation, that is his postulates now. Sir, so nucleus is positive in charge and electron is negative. Yeah, nucleus is positive in charge. Protons are in that, there are protons and neutrons. Protons are positive, neutrons are neutral. So that is the reason, because of protons it got the charge. Understood now? It got positive charge. Clear? Now, next is, he says that he has given like this: n is equal to 1 k, n is equal to 2 is equal to L, n is equal to 3 is equal to M. So like that here n is equal to 4 is equal to N. So we have K, L, M, N. Now he says that same thing. He copied the postulates of Rutherford Model, his master. Atom is spherical in shape, the entire mass of the atom is concentrated at the center part of the atom nucleus. Nucleus is positive in charge. Nucleus consists of protons and neutrons, and electrons are revolving in particular orbits. The remaining will remain. This is not there. Okay, so he says that revolving in particular orbits. Revolving in particular orbits. In particular orbits or or stationary orbits. Particular orbits or stationary orbits. Particular orbits or stationary orbits. So he says that as the size of the orbit increases, the energy associated with the orbit also increases. Energy associated with the, as the size of the orbit increases, the energy associated with the orbit also increases. Okay, actually in the textbook he doesn't start from here. Okay, he only gives 3 points in Bohr's model. If you see, he only gives 3 points. So that is as the energy. So next one is what? So here, as long as the electron is revolving in an orbit, it neither emits nor absorbs any radiation. This is the first point which is given in the book. There are only 3 points, but this is actually continuation of that. Continuation of these postulates. 6th and 7th, yeah, 6, 7, 8. So when an electron absorbs energy, it jumps from lower level to higher level, lower orbit to higher orbit, and vice versa. Okay, higher orbit. So that is EF minus EI is equal to h nu. Means when an electron absorbs energy, what happens? The electron will jump like this. This is EI initial and final. Okay. Next one. So next one is what? When an electron releases energy, it jumps from higher level to, it jumps from higher level to lower level, higher level to lower level, higher orbit to lower orbit. Okay. So what will happen now? So this is EI and this is EF. Okay. Again same formula, EF minus EI is equal to h nu. So next one is angular momentum. When an electron is revolving, so there is angular momentum. Angular momentum is moment of momentum. Angular momentum is given by that is mvr is equal to nh by 2 pi. Angular momentum is given by mvr. What is angular momentum? Moment of momentum. Moment of momentum. Suppose this is the nucleus. Electron is revolving in the orbit. Now see here, this is the r and this is mv. Okay, mv. Electron is revolving with a certain momentum in the orbit. So that it is producing angular momentum. Angular momentum is moment of momentum. Moment means torque. Okay, moment of momentum is angular momentum. Torque of momentum in simple words. Moment of momentum is angular momentum. So angular momentum is given by mvr is equal to nh by 2 pi. Clear? Chalo. Is it clear, Mr. Johan and Joshua? So do we need to buy heart all these postulates? Yeah, you need to learn these postulates, especially 6, 7, 8, 6, 7, 8, 9. 7 and 8 are same actually, same postulate. 7 and 8 is same actually, but here electron is when it absorbs, it goes to the higher level. When it is jumping from higher level to lower level, it releases in the form of light. Actually, what will happen? When an electron absorbs energy, it will go to the higher level. There it will stay only for 10 to the power of minus 9 seconds, 1 nanosecond, and it will again release the energy and come back to the stable, that is ground state. This is said to be ground state, excited state. It will absorb the energy, goes to the higher energy level. There it will live for 10 to the power of minus 9 seconds, and it will come back to the ground level, that is lower level, by releasing enormous amount, that is what energy in the form of light. Energy in the form of light. So this is the best example that the statement, like whenever you are upset or angry, never take any decision, and do not promise when you are happy. Yeah. Why? Because electron is not only for, see, when you are like upset or very angry, you say something and later on you regret. Okay. So the same thing happens here. This is the best example in the nature. Okay. So there it is only for 10 power minus 9, it will release energy in the form of light and comes down to the lower level. Clear? Now we will discuss about the energy, that is electron velocity and radius and energy of the orbit. Okay. Velocity, energy and radius of the orbit. Clear? Clear with this one? Okay. Now here, now we have to find out the radius of the radius, then we have to find out what we call the velocity of the electron. Before going, let me see, there is one more here. Yeah, see here, in electron orbit, electron orbit, An electron, see, when an electron is revolving around the nucleus, so what is happening? There are two. It is balanced with two forces, Fe to Fc. Fe means electrostatic force. Fc means centripetal force. When an electron is revolving around the nucleus, so what happens here? There are two forces balancing each other. One force here and the second force is like this. So one is centripetal force and one is Coulombic force. So centripetal force is 1 by 4 pi epsilon 0 into Z E square by R square. What is Z E? Z E is the nucleus. Or I will take electron only. If I am taking hydrogen, charge of hydrogen is 1 and electron is also 1. E square by R square. Again here mb square by R. This is the formula, mb square by R. Just cross multiply this one. R and R will go away. Cross multiply R is equal to what? E square by 4 pi epsilon 0 mb square into R. mb square. Okay, this is the radius we got. This is the radius mb square. This is the radius we got. After that, what we are doing? We want to find out the velocity. How do we find out the velocity? From the same equation we can find out. V square is equal to what? E square by 4 pi epsilon 0 into m into R. So if you want to find out velocity, V is equal to under root of, sir, we have chemistry tuition. Okay,
So
I will finish it
also
up.
go.
He is leaving it.
Can I also go?
Yeah, you can go. E square by 4 pi epsilon 0 into mr. These takes online also.
Yeah.
Okay. That is hybrid.
Yes,
So here,
sir.
yeah. So we can write like this. Okay. Okay. So V square is equal to E square by 4 pi. What term starts 5?
430.